So students, now we'll discuss in the materials and metallurgy the topic that is semiconducting materials. So as you can see in the image, we have various types of materials that have characteristics of the metals as well as the ceramics, and basically the electrical conductivity of the semiconducting materials lies in between that of a metal and a ceramics. Now their unique ability to control the flow of electric current, it makes them essential in modern electronics and enables the functionality of devices such as computers, smartphones, solar panels, and many more applications. Now, what are the characteristics of a semiconductor? So, as you can say, we have a lot of intermediary conductivity. So, semiconductors have electrical conductivity and lower than metals but higher than the insulators. Their conductivity can be altered through doping or external factors like temperature, light, or electric field. And also we have the energy band structure. So semiconductors have a small energy gap in between valence and conduction band, typically ranging from 0.1 electron volt to 4 electron volt. Electrons can move from valence band to the conduction band, enabling electrical conduction. When we talk of the temperature dependence, at low temperature, semiconductors behave like insulators. At temperature, as the temperature increases, more electron gains energy to cross the band gap, thereby enhancing the conductivity. Doping significant sensitivity, the electrical properties of semiconductors can be significantly improved by introducing impurities that are dopants. The types of semiconductors, we have intrinsic semiconductors, extrinsic compound, and we have in the intrinsic semiconductors pure semiconductors without any impurities, for example silicon, germanium. Extrinsic like duped semiconductors where impurities have been added to improve the conductivity. Types of duping, we have n type, p type. N type we have the adding donor impurities, p type we have the adding acceptor impurities. Now, when you talk of the compound semiconductors, they are made by combining two or more elements, for example, gallium, arsenide, indium phosphide, and silicon carbide. Now, if I come to the application of semiconductors, so first of all comes the electronic and computing, the foundation of integrating circuits and microprocessor used in transistors, diodes, memory devices, optoelectronics that are essential in light emitting diodes, laser diodes, and photodetectors. When you talk of solar cells, silicon, and other semiconductors that are used in photovoltaic cells to convert sunlight into electricity. Power electronics, wide bandgap semiconductors like silicon carbide, gallium are used in high power and high frequency applications. Electric vehicles and renewable energy systems, sensors, semiconductors that are used in temperature and pressure and light sensors for various industrial and consumer applications. When you talk of the key semiconducting materials, so I will explain here what are the different types of the key semiconducting materials. Number one, silicon. It has been mostly used materials in abundance and it has an excellent properties. Forms the basic of most electronic devices including transistors and IC circuits. Germanium, used in high-speed devices and early transistors. Gallium arsenides, high efficiency in optoelectronics and high-frequency applications. Silicon carbide and gallium nitride, widely used in high power and high temperature applications due to their wide band properties. Organic semiconductor, they are based on carbon-based molecules or polymers used in flexible electronics and organic LEDs. Now, when you talk of the advantages of semiconductors, we have miniaturization enables the development of small, lightweight, portable electronic devices. We have energy efficiency, essential for energy efficient circuits and renewable energy technologies. It is very versatile, can be tailored from various applications from computing to medical devices. High-speed operations, compound semiconductor support high-speed and high-frequency communication systems. Now, when you talk of the future trends in semiconductors, what are the future trends? Quantum computing, wide band gap semiconductors, 2D materials, AI, IoT, advanced lithography. So when you talk of quantum computing, semiconductors plays a vital role in building the quantum bits, qubits for next generation computing. Wide band gap semiconductors, materials like silicon carbide, gallium are advancing power electronics offering improved efficiency and reliability. 2D materials, materials like graphene transition metals are being explored for ultra-thin and flexible devices. Now, AI and IoT semiconductors are critical for powering the artificial intelligence and Internet of Things devices. When you talk of advanced lithography, extreme ultraviolet lithography, enabling the production of smaller and more powerful chips. So, these are the some of the brief information regarding the semiconductors. Thank you.